Okay. Get started? Okay, so we're going to start moving on. Because of time, we're going to shorten some of this, and we're going to not do the next steps, but I'm just going to show you what is happening so you guys understand it. If you're ever curious, you can try this out on your own. My belief is whatever I show you here, you're never going to want to do this, and the part of this exercise was to kind of show you how difficult this is, so that way when we give you tools, when we give you other tools, you know, it'll be a lot easier. Okay, so the next thing, we're going to start back over here at what message passing is, just to kind of remind everyone what are we looking for to from input. That's how we designate an EVM transaction. Now, theoretically, this is what it is. How do you do that with Fabric now that we've put the EVM in? And typically you would run, if you're familiar with the CLI, the pure CLI, right? The way it would work is you put it into those args, and the to and the input get pushed in, right? We're not putting from in. And the reason we don't need to do from is when you submit a transaction, you're signing it, and we get your public key from there. And the way we're dealing with accounts in our EVM chain code is we take your public key, we do a SHA-256?
It's
Ketchik, yeah, we do a Ketchik sum, which is a SHA-3 algorithm, but it's not the one that most people use. But we do that sum of your public key, and that generates an account address. But we can do that for you. We don't need you to input that in, so we're going to ignore you. We also think, you know, I don't know why you would want to input that in. You shouldn't have the ability to put someone else's account address too. So to an input, that's what we put in, and then again, you have to always do the EVMCC. Everything you do, you're invoking that. That's one of the main parts. And then to kind of show you some of the examples, so this is a SimpleStorage contract. I'm going to just go over it because we're going to use it for the next part too. If you're familiar with Ethereum development, you probably have already seen this as one of the hello world kind of examples. They have two functions, set and a get. Pretty simple. Then, yeah, I mean, that's basically it. And remember, this is how you do a contract creation. You do a to is the 0, the from is the account, and then the contract bytecode. So if you want to do this later on afterward, I have given us a file, scripts, SimpleStorage, and that there's a typo. It should be with an S, storages. We will fix it and re-upload these slides with all these corrections that we've been coming up with. If you open that file, all it's doing is exporting environment variables. Since we're not going to do this part, I will show you guys the file. Okay, so what we have there is the 0 address. Remember, we need that for contract creation. The next thing there is the SimpleStorage bytecode. So that bytecode, what it is if you go to Remix, Sol-C, some of the compilers that are out there, if you give it that file, that SimpleStorage file, it will generate this as the compiled bytecode. And then the next two things are get and set. Those are the function hashes, so they correspond. So that's when you submit a transaction, you have to put that hash in, so that way the EVM knows which function to run in the contract. So that's basically it. And if you remember earlier in the slides, we were listing out some of the core things that you need to understand about EVM smart contracts, and that's kind of what these are. So that's what that file does. We'll go back over here. The exercise here was basically you're going to invoke, first you're going to deploy the contract, then what results out is the contract address that you created, and then after that you can do transactions on it. So here you would input in for your args contract address and then the set and the value. All of this, again, is more to kind of show you what it really means to be interacting with the EVM. This is how it understands things. But we want to make life easier, so they have Ethereum clients. So we'll go through some of these things. We've already mentioned this a few times, but it's the Ethereum JSON RPC API. Basically, these clients that are created, they expect that the thing that they're talking to follow this API, and they really help alleviate some of the hard things. Like, I mean, if you're typing in little 643F to say that's the get function, as a user, as a developer, that's very confusing and it's not fun to deal with having to send messages. So obviously we have some clients. Now these clients, they expect, one, the API, but then there's something called the ABI, which is the application binary interface. It takes a Solidity contract and it gives out a schema, and it says there are these functions. This function takes in this many inputs, and it returns this type of an output, kind of things like that. So they don't have the core understanding of what actually happens in the function, but they have like function signatures and enough information so that way when you're creating contract or you're doing transactions, it's able to figure out the function hashes and all of that kind of stuff for you. Then things like Remix IDE, Web3, Truffle, these are example tools. These are probably the most popular ones in the Ethereum network. There are probably more. I think one that's up and coming is possibly EtherJS, I think.
Yeah.
Yeah, okay. So I think that's coming as a competitor to Web3. The idea is you can make applications in Web3 and directly talk to, you know, Fabric, or Fabric now, but previously it's to talk to the Ethereum network. So what we've created is Fab3. We kind of talked about this in that the tech set slide deck. Basically, the idea is your clients, you're going to connect it to Fab3. Fab3 implements the API, and it knows how to talk to the Fabric network because it uses a Fabric client. It's like a wrapper on the Fabric client. Yeah. So I think we already covered what Fab3 is, so we're going to make you guys do some more work. Hopefully people are familiar with Go projects. If not, there might be a few errors here, but I think we should have set you guys up with the Go path and everything, so we're good. What we're going to do is we want to build the Fab3 binary. Now I remember what I wanted to say. In this workflow, before we go into the building, if you're familiar with the Ethereum workflow, right, Fab3 gets replaced by something like get. Now the difference here is Fab3 is just kind of like a gateway. It's not a node, it's not keeping a copy of the ledger, it's not doing any of that. And it's important to know that distinction, that these two things are not actual parallels, but they're allowing us to use clients in the same way.
So it's basically the interface like Web3 JS for interacting with the blockchain.
Web3 is a client, right? And you connect it to something. Fab3 is like a proxy. So it's not quite the same. It's not like a library or something. Web3 would connect to Fab3. It's like, so this is an access point. This is not a full node. That's the distinction.
Web3 can also be considered as an access point, right?
No, I wouldn't consider
So basically, if you submit a transaction in Ethereum, normally what you do is either you have a local gas node, basically a lightweight node,
yes,
and you use Web3 to submit that transaction to the local node, or you use Web3 to submit transaction to some known or you trusted node. Right? Yes, exactly. So yeah. So in Fabric, basically Fab3 is the lightweight node, and you use Fab3 to submit a transaction to Fab3.
Okay, so let's get Fab3 running on your machines. So CD into the EVMCC repo. So if, you guys, I know in the debugging we might have opened up new terminals and you might have lost the initial exports, but that will be in GoPath, source, github.com, Hyperledger, Fabric, chain code, EVM, or there are dashes in that last part. And then you should be able to just do a go build -o fab3 fab proxy command main.go. You might be able to do make build. Stick with this. Oh, it's the dash show 60 on the other end. Can you just go dash show 5? Okay, I just want to quickly check.
You can run make build, but it's going to be in big directory. The chain code.
I can ask them to move it.
Stick with it. Or export the path. It's everything.
Just verifying that O does go there. I'm not sure this is a bug. Okay. No, you do all of these in that big
That's it. Yeah, you should have the binary go off here.
Oh, so in the doc control CLI, it goes through the inner bulk down to.
Oh, yeah.
How does it go?
Magically combined.
What does it mean? This is subject to the contract.
Oh.
And they see the usage type.
There's a box where you should have context. Okay.
Okay, so
You're expecting 1 point.
did you source these?
Yes.
Okay. Okay. Can you source the orders here? Or echo sheet? It's okay, we can just run this one against scripts.
We'll make it very copy-paste on Friday.
Source scripts, export orders.
We'll just remove that slash. Be careful about the dash. Yeah.
Okay, so how many of you have the Fab3 binary? Okay, cool. You got it?
The binary but not the network.
No.
It's a network.
Oh, network's not network.
Yeah.
So we'll just wait for a couple more minutes.
Will it reach?
Other questions?
Yep. So we are expecting a Go version at least 1.10. If you go a Go space version, if that's below 1.10, unfortunately you need to upgrade.
I just have one question. So here we are using Solidity contract. The EVMCC and spoke model like Fabric is. So if you look at the Fabric DAP system, there is not all nodes in. There is a hub that's ordered, right? And then there are spokes. That's not the case in EVM. In EVM, it's just everybody's a node. There's no order. So how does that not apply?
There is no order. So basically, when we import EVM, it's just a raw.
So people built the binary. If not, I'm just gonna start going to the next slide so we can start moving on a little bit. This is a pretty simple step, this one. I've also given you a script at the bottom so you don't have to do it, but I did want to show you what environment variables are being set because this is how Fab3 knows what to do. So the first thing over there is the fab proxy config. So this config is actually the configuration that is needed for the Fabric SDKs. It's actually the exact same thing. There's nothing special for Fab3. It's just the regular Fabric SDK. In there, it has a path to credentials, or not credentials, certificates. Those certificates are located in the EVM workshop directory. They're located in the EVM workshop directory, and if you look at them, they have all the CA certs. You need to talk to the. Oh, actually, sorry, I skipped ahead. In there, there'll be a link to the crypto config directory that got created when you did the BYFN generate. So those are linked in that config file. So this is how the Fab3 knows how to talk to Fabric, as well as have the right access points. The next couple of things, so these are things so the SDK knows where it has to target. So it has to be my channel. The CCID is the chain code ID. So if you remember when we installed it, we had the name EVMCC. That's all we're saying here. So this gives you, if you happen to install it slightly differently, you could change it here. Then the org one and the user, the reasons why those environment variables are there, it's so the Fab proxy knows how to parse through the crypto config directory and find the right user credentials. So that's why we need that information. And then basically what it becomes is Fab3 is one-to-one to one set of users, one user or one set of credentials. So you could type them out if you'd like, or you could source this in the workshop directory scripts local Fab3 bars.
Would that be the user account? Ethereum account, the user or?
No. So if you look inside of the crypto config thing and you follow it through, so if you pick one org and you check the users, under the users directory, there'll be a bunch of user names. It'll be like user1 at example. So that's what we're using here. It's really a way for the SDK to know the directory structure. You're basically telling it this is the thing. But in the credentials itself, it has no connection to the name. Well, kind of.
Probably a bit more explanation here. So Fab3 is basically built around the Fabric Go SDK. And then Go SDK expects the user credentials, so it knows how to talk to your Fabric network, or it has access to the Fabric network. And so basically you're starting Fab3 proxy, which loads those credentials. And when you submit a transaction, Fab3 will use these credentials to sign that transaction and then forward to your Fabric network. But in the future, when the Go SDK supports a offline signing transaction, which is supported already in the Node SDK. So basically you can have your private key, you can sign the transaction offline, and then just forward the signed transaction to Fabric network, through the Node SDK to Fabric network. But Go SDK at this point doesn't support that yet, but once it supports, we will definitely have that support in Fab3. But I just want to explain like what does Fab3 actually does internally.
So, do you mean that all transactions and all instances of chain code are running on the EVMCC with this user?
No. With this user, basically, you are using the credentials of this user to interact with Fabric, but the contract is running in EVMCC and is basically user agnostic.
It's user agnostic.
Yeah. Basically, if the user has the right access to Fabric network and has right access to EVMCC, then they can interact with the contract deployed in this EVMCC, basically in this channel. Okay, so let's run. Go ahead.
How do you map the user certificate, so identity within the Fabric world, to the key to interact within the EVMCC?
Oh.
Ethereum address.
It's the same as Ethereum. We are extracting the user address from the user public key. So if you interact with, for example, if you're using user 1, and your address will be determined from your public key.
And how do you do this mapping? It's in the local config file.
So the key, when you sign a transaction, you're going to send in your public key, right? So Fabric, when the EVMCC receives it, it's going to also see the certificate that was used to sign the transaction, right? The public key. And from the public key, we're using the same Ketchick sum of it. So that way we're generating an account address at that point. And we only generate it when we need it. It's not stored anywhere. It doesn't need to be stored because we can always get it from a user's credential.
Okay, so it's just a proxy in the end, so you're just...
Yeah.
So basically, as an example, if you deploy a ERC20 contract and you have, let's say, 100 tokens, you want to give 10 to another user, then you will be transferring your token to another user address. And then that address is only mapped to that user's public key, basically with this sum. And then you can only, in ERC20 spec, you can only transfer your own token if you are the creator of this transaction.
Yeah, sure.
Public key maps that. So that's.
And does it work with the same for the contract creation? Specifically what you do with contract creation?
Yes.
So who created the contract?
Yes.
So you also have this information. So we could have created the contract through the same proxy.
Yes.
Creating the
Yes.
contract.
We're going to do that.
Proxy as well. Okay.
Yeah, as the creator of the contract.
Do the command line stuff.
Yeah.
At all.
Yeah, you don't need the command line. That's why we skipped it, because we're going to make you do it the easier way. The initial goal was for you guys to see kind of bear down the grid, the lower level of what's actually happening, so you guys understand and you can translate. Because once we bring in the clients, we are abstracting away a lot of the message parsing and understanding how does a contract translate into this world. So that's what that first part was. Now we're moving to the second part where we're going to use the clients and show you how all the Ethereum tools, you can still use it to do all the actions that you're familiar with on the Ethereum network.
But so the key for the user 1 is being created when you set up bring your first network in the first phase.
Yes.
Just to be clear. So if you look in directory under crypto config, you'll find a hierarchy, and there's a bunch of crypto material that were created automatically.
Yeah, I get that. That's the Fabric key.
Yeah.
I was more wondering about the Ethereum and stuff.
So yeah, just as an example, this is what. Oh, I'm not showing you that. Okay. Anyway, if you have more questions about this step or how this is working, you can come and ask us afterward. Okay, so are we all done with this? Did we export our variables? Have we all built our binary?
We'll assume you do. So.
Okay. Okay, so the next thing, we're just going to run it. A patch just went in last week, so that output will not exactly look like it, but you will see the word starting fab proxy on port 5000. Yeah.
So do we have the Fab 3 running on your local host?
Maybe a show of hands. Okay. I hope people here are not opposed to raising hands at a conference like how. Okay, so, yeah. So we're gonna now connect with Web3. So we're going to use Node now, and hopefully everyone has Node already installed, and NPM. We will, but this is to, oh, should we skip?
Let's go to the
Okay, so we're gonna skip this part because of time. You have
yeah, we only have 1 hour.
We have an hour. Okay, so we're gonna skip it. If you're familiar with Web3, I'm just gonna quickly go through and tell you what the slides are doing. You're gonna install the directions we have are for the Web3 at the 20. I think it works up to 20.6 actually, that version. We don't have the instruction set for Web3 1.0. The API kind of changed a little bit. And yeah, so basically what we're doing here is, if you're familiar with Web3, you have to start to give it a provider. This HTTP localhost 5000 that points to the proxy or the Fab3 that we are running. Basically, the Fab3 acts as a Web3 provider, so you can do this. Then at the very end, you have to set that default account, because Web3 expects to be able to send that from part of the message that we completely ignore. So if you change this and put something else, we're not going to take it or believe you in any way. This is supposed to redo what we did. We skipped in the pure CLI. We're not installing the contract or doing anything that way, but this is another way you could do it using Web3. Actually, this was to interact with the contract that you already deployed. The next one is to deploy it, try it again and see how you use Web3 to do it. We're gonna try to make it a little bit easier, and we're gonna connect to Remix. So we would like you guys to go to HTTP Remix. Make sure it's HTTP, not the secure. If you do secure, it will not be able to talk to our Fab3 at the moment. Remix.ethereum.org. And in there, so I'll do these steps with you guys. So we're all in one page. You're going to upload poll.sol, SOL. It's in the EVM workshop directory. The next key thing is you have to select compiler. You have to do something in the 4, actually. It doesn't have to be 4.25, but that's like the last stable update in the 4 compiler, or version 4. So let me do this with you guys. So here, this is the compiler section. Just select 4.25 like that. You can see I already have the SimpleStorage contract, but we're going to do something different. So what you can do is go into your browser, open that up. Can people see that? Basically, you should be able to see this proposal. You should have compile here, and you should have like a green poll at this. Oh, it doesn't look green on this screen, but when you're on your window, it should look green. And then in the Run tab, I switched over. In this environment, you're going to put Web3 provider. You're going to say yes, and you're going to change this to 5,000. So let me know when we're all, or I'll give you guys a minute to get that far. We're going to make them deploy it, right? And then, yeah, we can make them invoke, and then we can show them when they invoke the DApp, if they see it. Yeah, and then when we do the DApp, they'll see that the results already have stuff in it. Yeah.
Can you just repeat the last couple of steps?
Yes. So you need to go to remix.ethereum.org. Make sure it's not the secure one, which I'm not at, but I'm not going to be doing this because I don't have the network running right now. Then here at the top left, there is like a folder. You could do that and navigate to the EVM workshop repo, and under contracts, there's a poll.sol file. You can upload that. Once you're there, on the compile tab over here, you need to make sure you're on a 4.25. If you select in the version 5, these contracts will not compile. Just to give you an idea why that is, because of this Pragma Solidity, this is using version 4 API.
So should it be 0.4.25 plus commit?
Yeah. And then if it's all successful, you should see this green, or this thing where it says poll, and you should be able to see that.
So click on the details.
Yeah, so just to give you guys an idea, when you're doing this development, this is a great tool, because as you go here, you can see that it has bytecode. There was that SimpleStorage's info file that's in the EVM workshop repo. All that information that was there comes from this details button. So you have that's the compiled bytecode. You can also see what the opcodes are supposed to be for the EVMs. You can see that it's broken down. This was the application binary interface that I was talking about before. So you can see it has what are the things. It's basically like a JSON. This tool also allows you to just kind of click these buttons and it copies it into your buffer. So then you have this. It also gives you an example of how to use Web3 and deploy this. These are the function hashes. This is the runtime bytecode. So what you can do, this is what happens when the EVM does the contract creation. It outputs a runtime bytecode. This will match that. So you could do a get code on a deployed contract, and you can verify that too. Yeah, so this details tab is very informative, helps you do a lot of development if you're playing with decentralized applications or smart contracts. And then the last step here is on the run. Go to Web3 provider, say OK, and switch this to 5,000. How many people have caught up to there? OK. So
You're not 5,000.
I don't have it running. So I can't do it. I'm going to pretend to use the JavaScript VM, and this will be proof for you guys that we're doing exactly what it's going to work here. It's going to work on your machines. We're not doing anything special here. So let me go through this contract a little bit. So the goal of this part of the workshop is we're going to deploy this smart contract. We're going to kind of show you a little bit of how you use Remix if you're not familiar with it. And then we have a decentralized application that we've already built for this contract. So you're going to run that locally and connect up, and you're going to see how they work. And that the application that we're using uses Web3.js to interact. So you can look through that source code too if you want to see how you can create an application like that. Okay, show of hands. Are we all at this stage? Okay. I'm going to hope that somebody stops me if you feel like we're going too fast. Okay, so here the first thing we need to do is deploy, or let me go through the contract very quickly. It basically takes in a list of proposal names. They have to be byte, they have to be in hex, they have to be hex encoded when you submit it in. And then basically you can vote on the different proposals, and it's based on the order you put them in. That's its index. So yeah, let's try that out. The app that we did, it does not really care about what you put into the proposal names, but all it cares about is that there are 4 options. So what I like to do is you're going to need an array. Hopefully you guys can see this. And then I'm going to just do this. This is A, B, C, and this is D, if you're curious about what those are encoded as. So you see this. I'm going to, so basically 0x61 to 0x64. That's what you need to put into an array. Then I'm going to open this tab up here. So down here, you should see a few things will start coming up. Let me explain. This account address is your account address that's being generated from your user credential. Fab3 is letting, once you connect to Fab3, Fab3 talks to the Fabric network to figure out what your account address is. The gas limit, this is just, this is not coming from us. You guys will also have, I think, the same gas limit. And I think, yeah, that's the only things that you guys should be concerned about. So once you have the deploy, go ahead and click the button. And you should see a transaction here. You'll see transactions recorded. You should get something more. Because this should be the first transaction we're running, because we kind of skipped all the steps of doing anything with the EVM. If it's not, then this, if you guys did those pieces in the PowerPoint, this might not transact. The actual block numbers will be different. So, where are we at? How many people have deployed their smart contract? Okay, I'm going to keep going. So, just to kind of test it out, so here you can do like proposals.0. You see all these blue ones down here. If you look at the deploy contract thing, the blue thing over here is saying that it's a query. It's not an invoke. So it's just doing like a read-only thing. The red ones are ones that are actually submitting transactions, just so you know. So proposal 0, it returns a name. The name is this 61, which is A, and it says the vote count is 0. These are the two things proposals returned. You can look here to kind of compare that. And then we're going to just do a simple thing, and we're going to vote for 1, or we'll start with 0. And then you'll see this. You should see the transactions recorded to go up 1. And then if you do proposal 0 again, you can see the vote count went up. This might take a little bit longer for you guys because it's going to have to talk to Fab3. And the first time Fab3 talks to the Fabric network, it's trying to figure out the network topology using the service discovery feature of Fabric. So the first couple of transactions or interactions is going to take a little bit longer.
Just so you can get proposal again.
Oh, I did. Again? Some more information about the remix. If you look in this log here, you can see where it says call. That corresponds to the things that are like blue. So call is what Ethereum calls like a query, and then the green ones are actual transactions, the little check marks.
Do you have a local thing running on your
machine? No, not right now.
I mean, basically, Remix can be run as a simulator. If you don't connect to any actual network, just use a JavaScript VM. At the upper right corner, we're using JavaScript VM, so that's just an in-browser simulator.
Yeah,
but you are supposed to connect to your local network.
Even if I try to use my in-browser simulator and it says that I don't know this, so what mistake? I just want to use the in-browser simulator.
You haven't deployed.
So more information from the remix. If you look at the logs, you click this little caret. It expands out, and you can see the more transaction information, right? So you'll get like the from, that's your account address. The to, you can see this is what the to should have been. That's your contract address. You can see input. I mean, they've kind of minimized it, but when you copy it, you can see what the whole thing is. So these are all kind of translate back to those things that we were showing you about message passing, so you can kind of see the details of your transactions here. Okay, so how many people have done this initial test? How many people have not? Okay, I'll give you guys a couple of minutes. Is anyone who hasn't done it stuck somewhere, and do they need help? Yes. Okay, I'll go here. But...
Oh, okay. Well, definitely. I think here you should have Oh. Oh, yeah.
Yeah. I mean, I think it's slightly different from because you can see this call is a script. It works. It's easier. And so we have a graphic UI.
The whole idea of this is
Now,
I can if I have a gap on
yeah, and then it quotes 061.
if I want to also run my gap, then this is what I do. And then the fabric becomes just one of the nodes that I migrate. So fabric.
No, we want to these two networks.
There is a change from 19 to 110 that causes the OSD to 119. So try to roll up from 1 to 11. It doesn't, I can help you get 110.
Yeah, so
I could write the whole version of smart contract.
Oh.
Basically, that's what it is. It's transferring the smart contract.
I'll come over there.
I mean, you don't need to write anything.
This is somebody here.
You don't have to write that. It's not only this providing most of the programs you have there.
Well, I mean, I don't think the version is something wrong. I just have to investigate the rest of the fabric is still
My tab,
that's the one.
all of them are registered at one time.
I gather. I've always been
So at this stage, we expect to choose okay on the that's because the message rate goes you can have sign when Go SDK is the no SDK for this then so I just saved users then the sign creation and after that
that's it. You're done.
It doesn't currently support that. No SDK does.
Like dim company, wahrscheinlich
This is on, is that what it's on?
So by the way, if you've completed all these steps, there's a ERC20 contract in the workshop repository. You can try deploy that as well, and then basically issuing your own token in your own network.
Do you know what the original part is? Oh, okay, and that's probably why all of a sudden they can't talk. Okay. Okay, try that out again.
I'll try it out.
Yeah, and do those steps again, yes.
So that's the token.sol is the ERC20 contract.
No, they need to still connect the DApp.
No, I mean just people on board. So I'm just saying if they want, you can try that. You can demonstrate it if you don't have that. Then just demonstrate it from him,
Yeah, we can do that. Okay. We're going to try to move forward. Okay, so let's go back to the slides. So what we've done so far is we've deployed an Ethereum smart contract to the EVM chain code that you've installed. Where that code is actually sitting is in the ledger, the actual runtime bytecode, and every time you submit a transaction, what the EVMCC does is it goes, pulls the runtime bytecode, loads it into the EVM, and then it runs your transaction on top of that. So just to give you guys an idea of what's happening, it's not deploying a new chain code, it's not storing any, it's not doing any of that. It's all operated through the same EVMCC. Okay, so now we're going to connect a decentralized application to the contract that you've already deployed. Yes?
Can you just repeat that last part? What you just talked about?
Okay. Can I answer that after? Just because we're running out of time, so I want to be able to show it. Okay, so I need you guys to git clone this repo, github.com, IBM, Hyperledger Fabric, EVM demo. And you can clone that anywhere. It doesn't really need to be in the Go path or anything. It is a Node.js app using React. Okay, and hopefully you guys have Node and NPM installed already. That was a step we kind of skipped, and now you're going to have to do it anyway. And then you're going to do it. So hopefully enough of you guys, I think everyone has a copy of the slides on their machine. So I'm going to kind of try to do this, show you guys what you need to change in that app. So in the Hyperledger Fabric EVM demo thing, under source, there is a file that says DApps.js. You need to change a couple of lines. Line 4, this is what it should say, HTTP colon // localhost 5000. So it has to point to the Fab3 instance. That's one. And then the second thing is this contract address. That has to be the contract address of the thing you deploy using Remix. The way you can get it easily is if you go to Remix. I have to do this again. Here, there's this button right next to your deploy contracts. That button, if you click it, it will copy the contract address into your buffer, and then you can paste it in to your into the file. So to give you an idea, this is again using Web3 to interact with the thing, with the contract and Fabric. So you have get account address, get contract. This is the ABI. So that way Web3 knows how to call the contract functions. And you're able to do things like this, voting contract, @ and then you can start doing things as my contract.vote, my contract, get contract. So those things, we didn't get to do this because we didn't do the Web3 CLI stuff, but this is a much better experience than having to write bytes and like say 0x613f and then put in your encoded arguments. You don't have to do it. You can kind of interact with your contract more intuitively. Okay. How many people are here? They've finished updating the address. Because I see the changes. Okay. So, I'm going to go back to the slides. You should, after you have done that, you can do an npm install and an npm start. And then at localhost 3000, you should see a decentralized application. Yes?
Where do you get the address from?
The which one?
Where do you get the address from?
Oh, you get the address from Remix. In the right column, there should be a deployed contracts thing, and there you should be able to get a contract address. So you are welcome once the app comes up. There is one thing, it'll show up a login screen. That login screen is not secure at all. If you go to the repo, they have the password in there. It's SOME-PASSWORD, so some-password. That's the password.
Very secure.
Very secure. So how many people have their app running and have logged in? Cool. And then go ahead, play with the app, vote a couple times. If you vote, you'll get to a results screen, and you should see that the transactions that you did previously through Remix should show up there. You should see the count, the vote count.
What's the password?
Some-password.
All lowercase.
Yes.
Can I point this to the...
No, unfortunately not.
Point this to
his local the JavaScript VM through Remix.
Oh, you don't have network running. Sorry.
Yeah. Okay.
But do we have the app in the cloud?
It's broken.
So we have, just broken.
Yeah. I'm trying to think if I have a version of it running.
Can you share your sheet so I can go short, right?
Yes.
Is this linked or is it just local?
It's just local.
Yeah.
So if you've already voted like before using Remix, you should have seen the result from the web UI as well.
Okay, so we have about 30 minutes left in this session. So the next part was where we were going to actually get you guys to use Fab3 to connect to a network that's already deployed and that you guys interact with each other. Unfortunately, I don't think we have enough time, but we can try it. But in 30 minutes, I'm a little doubtful it's going to happen. See, this is where the break was supposed to happen, to give you an idea. But I can start just going through the slides. So we have a Fabric network that's running on the IBM Kubernetes service. It has 4 orgs. It has 1 Fab CA per org and 1 peer per org. I'm positive this step would have taken us a long time again. If you did not have the Fabric CA repo, we have to go download it, install the binaries, and then the idea was we were going to divide you guys up into 4 orgs, and then we're going to allocate 1 admin per org, and they were going to go and generate user certs for everyone else. Register it, and then you guys would all get to enroll. And then there's a little thing we had to do to make sure these certs are in the right directory for Fab3 to understand. And we have 3 channels deployed on this network: Channel A, Channel B, Channel C. And org 1 and org 2 are part of Channel A. 3 and 4 are part of Channel B. And then there's a Channel C where all 4 orgs can interact. The idea was we're going to first start off with those A and B channels, and you guys could get to interact and kind of test the permissioning. So to kind of show how we're not losing any of the Fabric kind of pieces or components in. And then we were going to make you guys deploy ERC20 tokens using Remix. And then after that, what we wanted to do is connect over to Channel C, and then kind of make you guys create your own smart contracts using the token we would have deployed a token beforehand, and we can have a little bit of a, not necessarily a marketplace, but some kind of a little fun. So I don't think we have enough time to do any of that, but we could go back into some of the stuff that we skipped. Would you guys like to see interacting like with Web3, or are there questions? I know we kind of were rushing through before, so now we have some time. We can take questions. What do people want? This is when we need audience participation.
So let's say, first of all, how many of you have already loaded this web UI, like the voting app? Many of them, and you can successfully see the voting results previously from the Remix, right?
Yeah. Okay,
so basically, we don't have a gift to give out, but virtually everybody's a winner. But I mean, how does the admin get the certificate? Oh, we have the password. It's a very secure password.
Very secure. I mean, if you guys would like, we can do this, play with this. We're going to have to cheat a little bit. Initially, we're not going to do this whole distribution piece. We're going to just go straight to the open channel. Can you guys randomly pick an org? 1, 2, 3, 4. It doesn't really matter. Hopefully you guys don't use the same usernames because you will have a collision when you do it. But the first step is pick your org. Doesn't matter which one. You have 4. You're going to go to the workshop directory. And you're going to make kind of a folder to place all your admin certificates. So this piece right here is not necessarily specific to the EVM or anything. This is more of a Fabric thing. But you guys are here. You guys can play with this and learn how to do this too. Actually, before we do this, I just realized you need to do the previous step. You need to install the Fabric CA repo. Hopefully, we're not competing with bandwidth right now. And once you do it, it has to go into the Go path. And then if you do Go install, because your Go bin has been put into the path, this should automatically be available.
Probably just a bit more explanation here. We have 4 organizations, and each one of them has a CA. And we've created one admin per organizations. And we are going to let you to act as that admin to register for a new user for yourself. And then you will be using that user credential to interact with this deployed Fabric network. And to do this, you need Fabric CA command line, which is fabric-ca-client.
Show of hands, how many people have the Fabric CA binaries installed?